Construct a DFA for the language L over sigma with A and B such that the number of A's in the string is even, or we can say the number of A's is a multiple of 2, or number of A's is divisible by 2, or number of A's modulus 2 equals 0. In the last video we considered string length as even. Here just the number of A's in the string should be even. Then what all strings should be in the language? Strings in which number of A's is 0 means epsilon, B, BB, any number of B's. In all such strings the number of A's is 0. Then strings in which number of A's equals 2, strings in which number of A's equals 4, and so on. In the very beginning, automata will be in its initial state Q0. Now string is empty and number of A's equals 0. So such strings are to be accepted. Epsilon has to be accepted. Thus initial state itself is the final state. And from this state, if we see any number of B's, then also the number of A's equals 0. Such strings are to be accepted. So remain in the same state Q0, which now remembers that the number of A's is 0. From this state, when a symbol A is seen, now the number of A's is 1. So move to another state Q1, which is not an accepting state. Now Q1 remembers that the number of A's is 0 plus 1, or 2 into 0 plus 1. From this state, if we see one more A, then the number of A's will become a multiple of 2. Such strings are to be accepted. So we can move back to the accepting state. So generally this state represents, or this state is the memory that the number of A's is a multiple of 2, and this state is the memory that the number of A's is a multiple of 2 plus 1. Else we can say this state remembers that the number of A's is even, and this state remembers that the number of A's is odd. From Q0 we have a transition on A, we have a transition on B. From Q1 we have a transition on A. What happens if we see any number of B's here? Then we can remain in the same state Q1, which keep the memory that the number of A's is odd. So Q0 is the state which represents number of A's is even, Q1 represents number of states is odd, and here we need to accept number of A's is even, hence Q0 is the final state. We shall extend the previous question. Construct a DFA for the language L over sigma with A and B such that the number of A's is a multiple of 3. Or we can say the number of A's is divisible by 3, or number of A's modulus 3 equals 0. So what all are the strings in the language? Strings in which number of A's is 0, epsilon, B, BB, any number of B's. Or strings in which the number of A's equals 3, strings in which number of A's equals 6, and so on. In the very beginning, automata will be in its initial state Q0. Now the string is empty and number of A's is 0. Such strings are to be accepted. So the initial state itself should be the final state. From this state, if we see any number of B's, then also the number of A's is 0. Such strings are to be accepted. So remain in the same state Q0. And from the state Q0, if a symbol A is seen, move to a state Q1, which is now the memory that the number of A's is a multiple of 3 plus 1. From state Q1, if we see a symbol A, move to another state Q2, which is now the memory that the number of A's is a multiple of 3 plus 2. From the state Q2, if we see a symbol A, then the number of A's will again become a multiple of 3. So move back to the state Q0. So Q0 represents the number of A's as a multiple of 3. Q1 represents number of A's as a multiple of 3 plus 1. Q2 represents the number of A's as a multiple of 3 plus 2. And now it is not a DFA. Here we have a transition on A, transition on B. Here we have a transition on A. What happens on B? If we see any number of B's, we can remain in the same state Q1. And from Q2 also, if we see any number of A's, remain in the same state Q2. So Q0 is the state which is the memory that the number of A's modulus 3 equals 0. Q1 represents number of A's modulus 3 equals 1 and Q2 represents number of A's modulus 3 equals 2. And here we need to accept the strings in which number of A's modulus 3 equals 0. So we kept Q0 as the final state.